When we're talking about polygons, which are 3D shapes that have all straight lines that are fully connected and closed, there are three types of angles: central angles, exterior, and interior. So we're going to start with central. Central angles are angles where you connect two neighboring corners to the center. I can pick any two corners as long as they're neighboring each other and connect them into the center of my shape. So I wanted to calculate how big this central angle is. I can see that there are actually three central angles that go all the way around the entire center of my circle. So in the center there's 360 degrees, and so one angle is only one out of those three. So I need to take 360 degrees and break it apart or divide it by 3 to get 120 degrees for the central angle. If I have a quadrilateral, I have 4 central angles in the center. 1, 2, 3, 4. So I have 360 degrees around a full circle divided by 4 angles, and I get 90 degrees for the central angle. If I continue, I can look at a pentagon. The center is here. There would be 5 central angles. So this degree measure would be 360 to go all the way around the center, and I have to break that up into 5 angles, which would be 72 degrees, and I could continue for all the other shapes, continuing and continuing. So the rule for a central angle is that a central angle is always 360 degrees divided by the number of sides, or the number of angles. The other type of angle is an exterior angle. So we'll use our same paper here to do exterior angles. Exterior are the angles that are on the outside of your shape, but not the entire outside as someone might expect, but just if you take one side and extend it, then connect to the neighboring side, that would be your exterior angle. If I take this side and extend it, connect to the next side. Take this side, extend it, and connect to the next side. That's an exterior angle. Around my square, extend, connect, extend, connect, extend, connect, extend, connect. So you'll notice that they look to be about the same size as your central angles, and that's true. I have an entire angle up here that rotates, and then I go down, rotate again, go across, rotate again, and I have still turned a full 360 degrees around the exterior of this triangle. So the angle measurements are exactly the same. 360 divided by the 3 exterior angles is 120 degrees. For a square, 360 divided by the 4 exterior angles would be 90 degrees. For the pentagon, extend one side, connect the edge. Extend a side, connect the edge. Each of these exterior angles is 360 divided by 5 angles, or 5 sides, which would be 72 degrees. So if you have an n number of sides, the exterior angle is the same, 360 divided by the number of angles or sides for the exterior. Keep in mind, these rules are applying when you have a regular polygon, meaning all of the sides and all of the angles are the same. They're congruent. This would not work if your pentagon had 1 or 2 sides that were much longer or shorter than the others. Now I'll go on to interior angles. For interior angles, these are the angles that are on the interior or the inside corners of your shape. So the interiors are these ones here that they've already drawn in for you. Here's your interior corners. Now through math previously, we know that for a triangle, all 3 interior angles have a sum of 180 degrees. So that means if each one is the same, because it's regular, all the angles are congruent, each of these angles is 180 and divided by 3 for the 3 angles, which would be 60 degrees for each interior angle. On a quadrilateral or a square, because it's regular, there is a total of 360 degrees on the interior. If you didn't know that, you could split this up into 2 triangles. The lower left triangle has a sum of 180 degrees in its angles, and the upper right triangle has 180 degrees for its angles. So the total sum of the interiors is 360 degrees. So each interior is 360 degrees split up into those 4 corner angles of the square, which would be 90 degrees. Let's do a few more. On a pentagon, I can take a pentagon and split it up into triangles, pick one corner to start from, and divide it up into triangles. There's one triangle that makes a total of 180 degrees in the interior. a second triangle of 180 degrees, and a third triangle of 180 degrees, which makes a total sum of 540 degrees. Then if I take that 540 degrees and split it up into the 5 interior angles, each interior angle is 108 degrees. On a hexagon, same process. Pick any corner to start, break it up into triangles. I can see there is 1 triangle, 2 triangles, 3 triangles, 4 triangles. Each one has 180 degrees for its interior corner angles. So that would be a total of 720 degrees. Notice the pattern that as the shape gets bigger, the triangle was a sum of 180, square was 360, pentagon 540, hexagon 720. Each time it increased by 180. There is a general rule for this. The sum of the interiors is always the number of sides minus 2, because if it had 5 sides, it only made 3 triangles. If it had 6 sides, it only made 4 triangles. So the n minus 2 tells me how many triangles there were. 6 minus 2 is 4 triangles, or number of sides minus 2, number of triangles, and each triangle is times 180 degrees to get a total sum of those degrees. Then to calculate just one interior angle, we would take that sum, for example the hexagon, 720, and divide it by however many angles or sides there are. In this case there are 6, which would be 120 degrees. So our interior angle calculation is always going to be the sum, n minus 2 for the triangles, times 180, and divided by the number of angles or sides.